Alright, welcome to part 2 of measuring and units. Now we're going to talk about volume. And while mass is how much matter there is, volume is how much space the matter takes up. So if we assume that these have the same amount of dots, which one takes up more space? The one on the left, letter A. And we measure volume in liters, sometimes milliliters, and we said that A has the most volume because it's taking up more space. So let's look at these three containers. We have air, we have feathers, we have sand. So mass is how much matter is in the object, and volume is how much space the object takes up. And so if we look at these, do they have the same mass? Do they have the same amount of particles in them? Or do they have the same volume? Do they take up the same amount of space? If you picked volume, you are correct. Now, if the volume's the same, what do you think is different? The mass or the volume? Remember, we think mass is similar to weight because we measure it on a scale. And so if we think of air, feathers, and sand, they definitely have different mass. And which one has the greatest mass? Which one has the most amount of stuff in it? The sand. If we put the containers on a scale and with the same volume, the sand would have the greatest mass. And so we measure mass in a graduated cylinder. This tool is the most accurate tool. So don't grab a beaker, don't grab a flask, don't grab a test tube. You want the graduated cylinder, the one that has the numbers on it. A lot of times it's milliliters. If you are dealing with a really big volume, it'll be in liters, and we'll talk about the difference in the next section. And again, this is the only one that we use to measure volumes. So what do you call an educated tube? A graduated cylinder. And so when we're using this graduated cylinder, if you look at the liquid, like we see in this picture right here, a lot of times we see that the liquid kind of clings to the edges and creates this kind of concave, convex concavity right here. And so we say, and this is because of surface tension, and we'll talk more about that later on. But we say that the true volume is at the middle, the vertex of the curve. And so in this curve right here, it wouldn't be 22, but just 20, because that's where the center lies. So take a minute, think about these three. So if we look at this one, these are increments of 1, because if we count them all up, so 85, 86, 87, 88, that meniscus falls kind of in the middle, so we're going to say 88.5. On this one, same graduated cylinder, 91, 92, that's about where our meniscus falls, so this one would be 92 milliliters. We're going to assume that this is in milliliters. And this final one, we go all the way to the middle, and that falls right at 90 milliliters. So this would be 90 milliliters of water. And you're like, Miss, I'm not measuring the volume of the water. I want to know the volume of my object. And so the way to do that is to take your final volume, what you get when you put the object in the water, minus the initial volume, how much volume you had at the beginning. So when you subtract the 2, that's the volume of your object. For example, if we have 10 milliliters here, and we started off with 5, 10 minus 5, the object is 5 milliliters. On this one, we have see, we are, looks like in increments of not 0.1 but 0.2, 2.0, 2.2, 2.4, 2.6, 2.8, 3, 3.2, 3.4 is what we have with the green object. And we started with 2.4. 3.4 minus 2.4. This green object has a volume of 1 milliliter. And you can also take volume geometrically. If you have a cube, you can just do it length times width times height. Or if you have a pyramid, you can solve for the volume that way. But for objects that are irregular, we use this dispersion of water, how the water level changes, to tell us the volume. So what tool is volume measured in, and what units is volume measured in? So if you said the graduated cylinder, you are correct. And if you said milliliters or liters, you are also correct. And that's the end of that.